now I'd like to invite on this stage my colleague Christian Lecomte, who will give you an overview of sheet metal possibilities in BricsCAD Mechanical. Thank you.
Thank you. So, I am Christian Lecomte, and I have been in the business of sheet metal CAD for more than 32 years. That gives you a big clue. I am older than 32. And there is another clue, my accent. Despite my effort, I cannot hide my nationality. So, the question is, why do we need a mechanical CAD, and especially sheet metal CAD? Among reasons, there are three main reasons. First, design. Design part, design assemblies. Second, produce all material and document for manufacturing, prepare for manufacturing. And the third is exchange data. But as Dmitry said, exchange data is not only import-export. It is import and be able to rework. And this is what BricsCAD do very well. All the group and the industrial company has now a multi-CAD environment. And anyway, from the idea to the manufacture, there is many CAD involved. So, first, let's see how to create from scratch. We start from the upper assembly. And you will see that this part, those two parts are missing. So we will create them from scratch. And we create them on the assembly. And we will use the existing part to be sure to fit to the assembly. So first, we create a profile in this direction. We help ourselves with the existing part. And now we will create another profile in the other direction at 90 degrees. So we can also use some point of the assembly and give the dimensions that we need. Okay, this is now how to create the second assembly. You will see that if we make a mistake, for example, for the height, this is not a problem, because we will use the trick of combining two extrusion. Then we will finish the first profile in adding a fillet. No, chamfer. I told you. So now, two extrusions, and then we will combine those two extrusions, and we get the solid. But it's solid, it's not sheet metal. Then we will, of course, isolate this solid and cut in two, because the result must be two parts. So we will cut this solid in two parts, and then it's still solid, and we will shell to get something with a constant thickness. And then we will apply our powerful sheet metal features. Then just in clicking, then with all the bands are created. Automatically, the junctions are created, and we can switch a band to a junction to be accurate. Then we can add on the back 4 new flanges, 5 new flanges, and you see that the meters are created automatically. It's magic. So, and of course, the part can be unfolded. You see, as it is fast. The second part, we will create 2 bands. We choose to create 2 bands, and then we will create automatically all the junction. And you see, it's very important, then we create junction not only on straight line, but on curves. And that's unique. And then we will create also those 3 bands, 3 parts, 3 flanges. Okay, and it's finished. And this can be unfolded. Of course, the big band is recognized automatically as a lofted band, so made step-by-step bending. Of course, you can change if you want, but by default, it's like that. So now we will replace, in the assembly, we will replace the solid by those part. This assembly now is ready to be manufactured. So we will complete the second goal, produce the document and material for manufacturing. So we will launch the batch application that will examine all the parts, sort the part between sheet metal and non-sheet metal. The sheet metal parts are automatically unfolded. And the system automatically creates folders, different folders, and save the DXF, the result of the unfolding, in the appropriate folder, sorted by thicknesses. So this, the duration of this sequence is 3 minutes. 3 minutes. 3 minutes for this assembly. You can imagine doing that manually. It would be a nightmare. And most of the CAD system today, if they can unfold correctly, but do that manually. So another thing I have to insist is that we don't know. At the beginning, I didn't say if the assembly is our assembly or an assembly coming from outside. For us, it's exactly the same. We can do that. This sequence, we can do that with our assembly. We can do that with a step file. That's very important. We don't import a step file just to see. Okay, we can rework and make this complex batch with DWG, BricsCAD file, SolidWorks file, step file, and so on. So we will wait for the result. There are a lot of parts. So you see that's why it takes 3 minutes, 3 minutes and a half. It's time for pause. BricsCAD work for you. Okay, it's, no, there's still some, so, no. I will show you this unfolding. It's very, very beautiful. Oh, oh no. You see our two parts. Okay. Now let's see what we get. We get a report with sheet metal parts. All the sheet metal parts are unfolded, and we get also some parts that we call poor sheet metal. Poor sheet metal means that can be sheet metal, but there is a problem. There are a problem to convert or to unfold. Ilya, can you show the unfolding of the cabin, because it's quite. So you see that we have. You see the kind of unfolding, complex unfolding that we do. Okay, come back to the report. And then we have a problem with the part which is a poor sheet metal. This is a good example. So we will open it and see what happened. But if we zoom on the corner, we see that it is not sheet metal. It is just a solid, just a shell. And we will use now our tools, and we'll see that very quickly. We will select all the vertical and tilted lines and transform in junctions. Then you see that now we have junction, and just in clicking on bend, and that's all, the bends will be created automatically. So the junction and the bends, it takes about 2 seconds, maybe 3. So now we will use our smart split command, because we cannot unfold if we don't make those split. Unfortunately, we have to do that 8 times because there are 8 corners. But this is quite quick. And the part, of course, will be unfoldable. This is important. So you see that this part is a part coming from. We don't know. It can be a step. It can be SolidWorks. It can be anything. But in 3 or 4 clicks, plus 8 because of the 8 corners, we create a sheet metal part, correct? And then we can unfold. Okay, we have unfolded the part. So you see that we have completed those 3 goals. First, design. You have seen that as it is quick to design from scratch, just 2 profiles, shell and split at the appropriate corners. Secondly, produce document for manufacturing. This is just like that. You don't have anything to do. BricsCAD works for you. And if there is something in the import model that is not sheet metal, we can rework and transform in sheet metal. And this year, thanks to new features, it's faster than ever. Thank you. I will give word now to Dmitry for the conclusion.